73.89. Oh, don't worry, Elza. We're going to do the same thing over and over and over. So 76 point, what did I say? 73.89, okay. Lithium carbonate. We can go ahead and do the math. 73.89. All right, and that number turns out to be 56.17, which we're going to round to 56. Okay, so if we wanted to make 76 grams of calcium carbonate, according to this chemical equation, using these two reactants, we would go ahead and add in 120 grams of calcium nitrate and 56 grams of lithium carbonate. Okay, so that would be how many of each we would need to make that amount of product. Okay? How is that one? It's good, right? You know, nothing too crazy here. It'll get worse, as always. Okay, let's see what Marissa's got to say. Yep, I have two curveballs to throw at you today. Kind of confusing. Okay. Allow me to... We'll do a graph, okay? Okay, this is all we are adding in. I would not do that, Marissa. Oh, I mean, yeah. That would totally work, actually. For lithium nitrate, yes, you could totally do that. Because now you've found 3 out of your 4 things. ARPAN, they don't add up to 76. Because we also have this guy. So remember, the reactants... The mass of reactants must equal the mass of products. But in this case, we have 2 products. So this one would be 76 grams. That's what we're looking for. And since this is 176 grams, we would assume this one would be about 100 grams. That's where the other rest of the mass is going. Marissa, if you were to do this calculation, you would put the 2 in there. But if you're going to use law of conservation of mass, you do not need to worry about coefficients. Okay, because the numbers have to equal each other. Okay, so we'll keep going. Okay, so this is all we are adding in today. And this is going to be the coefficients from your chemical reaction. This is the only way we are able to convert from moles of one substance to moles of another substance. So far in chemistry, we've been working with one thing at a time. One solution, one compound, one gas, whatever it is. And so now we're learning how to transform one compound into another compound. Okay, so that is going to be from our chemical reaction. So the whole point of doing all of this stuff up till now is to get to here. And so we know a lot of ways actually to get moles of one substance. So one way we have, we can go from grams of A and we use the molar mass. Right? We can go from grams to moles by using the molar mass of A, whatever that happens to be. And if we want to convert from A into B, we have to use the coefficients from our chemical reaction, whatever those happen to be. Anyone remember any other ways to get moles besides molar mass? This could work either way. Yeah, we could totally go to grams of B by using the molar mass of B. We can totally do that. We can get grams of B that way. So yes, technically you're correct, Samville, but nobody ever likes to do that. So let's not even worry about Avogadro's number right here. He means divide, I think. Yeah, just divide by. So this is... Oh, how interesting. One of our fellow faculty members is calling me. I won't pick up. Okay, so... Anyway, anyone remember any other time we've used moles in this course? Any ways at all? I'll give you a hint. We did something with moles last week. It has been a weird semester. This is true. Okay, fine. So, who remembers their gas laws? Yes. We can use P, V, or T to get moles as well, right? Because we know PV equals nRT. That's another way we can get moles of something. Again, my head is in the way, I'm sorry. So we can, if we have a gas, we can use PV equals nRT to get moles. Okay, and another way that we had, I'll just do this one in purple, just because the volume of A, we can use the molarity, right? So that's one we did last week. So this one is solutions. So depending on what we have, if we have a mass of a substance, we can use its molar mass to convert it into moles. If we have the volume of a solution, we can use its molarity to find the moles of that substance, right? That was the concentration. Or if we have pressure, volume, temperature, any of these gas properties, we can figure out what the moles are, right? We have 3 ways of coming up with moles that we've talked about this semester. And I know it has been a weird semester. All right, and so we would use those exact same things. We could use the molarity of B to find the volume of B. And we could use PV equals nRT to find PV or T. How exciting. I know this looks totally crazy, and it kind of is totally crazy, but this is kind of a big chart of everything we've learned in this semester, right? Pretty much. So we're using molar masses if we have grams. We're using molarity if we have a solution. Or we're going to use the ideal gas law if we have a gas and we have other properties. Okay, and once we get that moles of our first substance, we use our reaction coefficients to get the moles of our second substance. And depending on what quantity we want of the second substance, if it's grams, we would use molar mass. If we wanted to know the pressure or something, we would use the ideal gas law. Or if we wanted to know the volume of a particular solution, we would use the molarity. Totally crazy, but we have an hour and a half to see all of this in process, okay? So, let's keep going. Alrighty. So, let's go ahead and do one where we have gases, maybe. So let's say we are going to burn hydrogen and make water. We have a fancy hydrogen fuel cell car. Throw some coefficients on there. Balance it for you guys. Okay, so let's say we have... this is not combustion, Samville. This is just this is a combination reaction. Combustion always has to have carbon. Yeah, you're right. And so it would have carbon dioxide. But not combustion. This is just a special type of combination. Okay, so let's say we have a, I don't know, 20-liter tank at 300 Kelvin with 1.26 atmospheres hydrogen. Okay, how many grams of water can this make with unlimited oxygen? So we can use this information. All right, so we always want to start with whatever information we're given. So in this case, we are given 3 properties of a gas, right? And we are looking for the mass of a substance at the end. So we want to somehow we have a volume, temperature, and pressure. We want to somehow end up with grams of water. Yes, so we are certainly going to do that. So first thing we're going to do is get moles of hydrogen. And from that, we're going to get moles of water. And then from there, I don't know why I left such a big space, but that's from where we can get our grams of water. Right? We're using whatever quantities we're given to find moles. From that, we use our coefficients. And then whatever moles of our desired substance we have, we're going to use the appropriate conversion to get it into whatever unit we want. So in this case, we want grams of water, and we're starting with gas quantities. So we know N is PV over RT, right? Just solving the equation for N. What's our pressure here? I'll do this in blue just because black is getting boring. And our volume? $10. 20-liter tank, yeah. Yeah, I just keep scrolling up so we can see the problem again, Zoe, that's why. R, as we know, 0.08206. And the temperature is... What is the temperature? 300, yeah. Okay, so this number will equal to moles of hydrogen. Okay, so doing the math, let's see, 1.26 times 20 divided by 0.08206 divided by 300. Okay, so I got from that something that I've blocked. Okay, there it is. So in this case, why did I put moles there already? From this we got 1.02364 moles of hydrogen. Okay, and looks like we have 3 sig figs, so let's just remember that. Alright, so we have done our first step. So now we need to go from moles of hydrogen to moles of water. So we can do that. What, I know, Zoe, you're going to get mad I'm scrolling up, but what numbers are we going to use here? What's going to be on top and what's going to be on bottom? Alright, I'll humor you, Marissa. If we do that, what's the unit going to be? Okay, fine, I can fix that. I can swap it. So we end up with grams of hydrogen. And how does that help us? It doesn't, exactly. So, don't do that. This is not what we're looking for, so not what we're going to need. So if we look back to our plan, we want to go from moles of hydrogen to moles of water. Alright, and so Tiffany had suggested we'll use the molar mass of water. But we have a problem. If we look here, our units do not cancel out. We're going to have moles of hydrogen times grams of water divided by moles of water. So moles times grams divided by moles. So, that's very close, Kimberly. I would not write it that particular way, but that is where we're going. So this one also not going to work right now. So 1.02364 moles hydrogen. We're going to actually put 2 moles hydrogen and 2 moles of water. So you always want to put your reaction coefficients in. Okay, so yes, even though they are the same, they will cancel out. It's always better to just get in the habit of writing exactly what they are. So we know that 2 moles of water and 2 moles of hydrogen is what the ratio is. So these are just our reaction coefficients. Okay, and now, Tiffany, we can go ahead and do our 18.02 grams water per mole water. Okay, and then, so, let's do that. Okay. Doing all this, we get 18.44 or 45, but how many sig figs do we need from this nonsense? 3, yeah? Okay, so that 5 is going to matter. Oh, actually, no, it's 446. So 3 sig figs will round to 18.4 grams of water. Okay, I know this can be strange, and I realize again my head is in the way. There. So I'm gonna scroll up again. I know this is gonna make Zoe mad, possibly some of your others again, but all we're doing here is, in this case, we are going this route. We are going from this to moles of B to grams of B. This is the route we've gone here. So we've gone from our gas. Yeah, the 2 moles H2 is from our chemical equation. So the 2 here, this 2 that I've just circled is that 2 in our conversion formula, as well as this one. Okay, so this is the route we've gone this time. We went from PV and T to moles of hydrogen in this case. We went from moles of hydrogen to moles of water, and then from moles of water to grams of water. Okay, I'm going to just go ahead and undo all of that because we can keep referring to this chart. Oh no. Okay, got it. Okay. Do we have questions on this particular problem? We are going to keep doing these for the rest of the time. Okay. All right. Then, how about we do your lab? You guys want to do your lab? I think you do. Yes, please. Okay, so you had oxalic acid, right? We did that yesterday, Robert. But right now I'm downloading GTA 5 since it's free. So yeah. I don't technically have Blizzard notifications. I have other Discord notifications. So, but that's a separate matter. We'll deal with that later. Okay. So here is our reaction. By the way, don't get used to me balancing it for you. Again, I haven't written the test yet, but you always want to. Tiffany, here's another thing for you. Practice balancing your equations, okay? That's going to definitely help you out. So remember on Canvas, I did put a bunch of resources for you guys. Let me just go ahead and show you again what I have for you. So you can see all of the fun practice stuff that you guys have. Okay, that'll get you, the more you practice it, the faster you guys are going to get. Okay, boom, here we go. So all this stuff, this should be the first thing that you guys are going to see when you log on to Canvas, is all of this practice stuff. This one is going to be a very useful one for you right here, this identifying and balancing. There's 100 problems, so I mean, you guys can just keep doing them forever. So in this particular one, it's someone else's quiz. Just choose the 100 problems and do both. And it'll give you a bunch of stuff to deal with. Here's the 100 problems for you to do. I know. And then you can do the graded and it'll correct you and you can see what you've gotten. So tons of stuff you can play around with. So you're going to get your reaction coefficients. You're going to be able to identify it, what type of reaction it's going to be. Of course, if you don't want to do 100, you could choose a smaller number. You could do 10 problems, for example. Okay, so that's definitely something there I would definitely suggest doing. That'll definitely help you guys out. Okay? I know, this sucks, but think about it. We only have 2 more weeks, Zoe, so after that you can do whatever. Okay? Back to this stuff. Where's my head? There it is. Okay. So, let's say you guys had I don't know what numbers you guys have, but I'll make them up. Where is my head? Story of my life, indeed. Okay, so in this case, the point of your titration yesterday was that you do not know what the molarity of the sodium hydroxide was. That was the point of doing it, was you were calculating that number. And you were starting with a mass of oxalic acid, I hope. I still can't believe he only did 15 minutes with you guys. Like, that's just ridiculous. But I digress. Okay, and so the whole point of doing this thing with the burette is that you get an exact volume when you do it. So let's say you did this titration and you got 21.62 milliliters of NaOH. Alrighty, so I want oh my god, 13 minutes. That's just awful. And I can't believe he hung up on you guys. Like, just, god. Okay, so at least on this part, we know what we're looking for. This is what we're looking for. Okay, so from these numbers here, which one of these can we get moles from? Yeah, we can get moles from our oxalic acid. So let's go ahead and start with that. Alrighty, oops. And you know what, I'm going to just go ahead and make this into liters. It'll just make it easier for us. Oops. Not what I meant to do, not to cross it off. Okay. 0.02, what did I say, 2163? Something like that. Okay, good enough. So, start with whatever you can get moles of. Oh, in fact, this was also a dihydrate, right? I think so. Yes. So for this particular one, we can say that this particular mass of acid was titrated with a certain concentration of sodium hydroxide, and it was found that 0.02163 liters of sodium hydroxide was needed to complete the reaction. What's the concentration of sodium hydroxide? Like, that's how I guess I would phrase it, or something like that. But this one is more for your lab, so I want you guys to be able to do this one. So, okay, so molar mass of this one, 126 grams for 1 mole. Again, I normally would not include a hydrate on a question I would give you, but since the lab incorporates the hydrate, there you go. Okay, from this, which substance are we looking to get? Like, if we're going to use our coefficients here, what are we looking for? Are we looking for water? Are we looking for sodium oxalate? Or are we looking for sodium hydroxide? Yeah, we're looking for NaOH. So we know we want moles of NaOH on top. And we're going to get rid of moles of oxalic acid. Okay, and so the numbers we're going to put here, again, I'm just going to kind of circle for us. We're going to put 2 moles over 1 mole. Okay, those are the numbers from our reaction. Alrighty, so let's go ahead and calculate. Where's my calculator? Here it is. So 0.5365 divided by 126 times 2. In this case, we have 0.00851587 moles of NaOH. Okay, from this, it looks like we have, let's just say 4 sig figs. Okay. So, if we remember, we are looking for... Was that one of you? No, that's someone else. Okay. Looking for molarity of sodium hydroxide. So, who has an idea of how we're going to use this number to get the molarity? Let me go back to what we're given here. How are we going to use this number and this mole number together? How are we going to use those to find molarity? Yeah, right. We have to remember that molarity equals moles over liters. And so, all we have to do is put our... It's not a delta. Divide this by whatever liters we had. In this case, 0.02163 liters. Okay, and that number, we do it. So I think this is the exact calculation you're doing for your lab, but with like different numbers. 7 divided by 0.02163. And so in this case we get 0.3937 molar NaOH. Okay, and that is our answer. So, in this case, if we go way back to our handy-dandy chart, this time, whatever, let's use blue, we started with grams of A, and in this case, we were doing this particular pathway. We were going from mass of one substance. In this case, we were looking for molarity, but because we already knew the volume of B. So we were just looking for the conversion factor there. But again, the key point here is that we're using these coefficients from our reaction to convert from one substance to another substance. Okay, that's the big thing here, this middle part. Okay? So, we always want to find moles of whatever substance we're looking for. That's kind of the big thing. So if we were to just kind of summarize, we want to use what you have, are given, to find moles. All right, then use your reaction coefficients to get moles of B, let's say. So it is, Melissa, because it's a dihydrate. So if you were to calculate it just using H2C2O4, you would get 97 or something. But since you have two waters tacked on there, it's going to be 126.07. It's the molar mass, yeah, of the dihydrate of oxalic acid. Yes, for this one, Elsa, for your lab, because the solid that you would be using in this lab is a dihydrate, that would be part of your molar mass. But again, I'm not going to give you, on your exam, a hydrate as part of your reactants, because that's just silly. But in reality, you will often be dealing with hydrates, so that's why in the lab, in this case, you have it. Okay, and then, I mean, this is really all we're doing today. We're using what we are given. That could be mass, that could be PV equals nRT, that could be molarity, whatever it is, to find the moles of A. Whatever, and so just A is given substance, and B is desired substance. Okay, whatever those are. If it's water, if it's hydrochloric acid, whatever the heck the problem is asking you to do. Okay, so it's really just 3 steps. I can move my head down there. So we'll use whatever you're given to find moles of A. You use your reaction coefficients, and then you take moles of B and use it however you need to find your reaction quantity. Yeah, we're going to break right now. I just wanted to kind of do a quick little summary thing. Okay? Yes, true. Balance equation. Three-eyed happy face. Okay, there we go. Perfect. Okay, go ahead. Let's take our break so Zoe can eat. Let's come back at 4:43.